On Tuesday's video, we talked about jump and loop instruction. So after you see more loop example, let's go over. Earlier we talked about to find the sum of an array, and we make a copy from the string. So instead, we just manually repeat to do the instruction again and again. Can we using the loop to know how many times we need to do the copy, or how many times we need to add the new value into the sum? So then we will update the sum of array and the copy string, the 2x and ASM file we talked about earlier. So the first one, let's talk about finding the sum of an array. If you remember on Tuesday, we talked about we have one array W. So you have your word data type. So then you have the value is 1000, 2000, and 3000 each. So we can using the indirect operand, because the indirect operand, we will save the offset of the array W into the EXI. So then here we can using the EXI to traverse around the array. Copy over how they look like, right? So we're using the EXI to traverse around one by one. They start from 1000. So then we add the type of the array W. So then the EXI will traverse to the next one and go to the next one. So that's what we have before. So when we want to find the sum of the array, that's why we know you will just have the EXI have the array W offset. So you move the first value to AX. So then you just need to increment your EXI using the type operator. So EXI will add 2 and access to the next element. So then we add one more. So after you access the next element, 2000, so then we add that to the AX. So continue, we know we have one more element. So that's why we just add EXI again. However, nothing wrong when we find the array sum like this. But one thing is, we never know in the array W. For example, I give you an array. I may not know how many elements we have. So that's why, remember, in C++, we do the for loop. So then you need to know the element of how many elements in the array. So the same thing now, if I want you just write a code, can generally, no matter what kind of array I pass you, you should find the sum of the array. So how can we using the loop instruction to update this example we have on Tuesday? Right, so that's why here, right, we just need to using the loop. So now you know the loop instruction, you know how to write the loop instruction. So you still have your EXI save your array W value. You have your AX will keep the sum. But one thing is, how many times we need to do the addition. So that's why remember when we write a loop instruction, your EAX is always your counter. So here you have 1 element, 2 element, 3 elements. I need to do 3 times to move the EXI one by one to add to AX, right? Right, so did you remember before? How should we know the operator for the size? Okay, for the element of the array. Right, so now we can use the length of. So when you use the length of, I don't need to know this array how many elements. Actually, I just need to do the length of operator associated with this data label. So then I know how many times I need to add the EXI value to AX. So that's why here, before we start our loop, so your loop can start from your jump code label. So then you have your loop to see, do you need to go back? So every time when we into the L1, the first thing I know the EXI value. So then I dereference that. So don't forget, you need to dereference that. But this one actually, because you add, you either write you need to write a dereference. You know you need to find the value here. So then here, because you save in AX, So then they will read the 2 bytes. So the EXI value actually add to AX. So we get the first 1000 in AX. But before we will go to the next one to add, right? Right. So that's why now your EXI need to increment according to the size for each element. So that's why your EXI will using the type operator. So the type operator associated with your array W. So then they will add 2 to your EXI. So that's why before the loop go. Okay, so then EXI actually is here. So then you jump to because the loop condition, the loop before you jump, you will check the condition. So the first thing, ECX equal to 3. I decrement first, become 2. So 2 actually is not equal to 0, so that I jump to the L1. So after you jump to the L1, right, the EXI already point to the next value I add to AX. So now AX has 3000. So again, then I just need to add the type of array W to EXI. So that's why the EXI now move to the next value. So then, right, so then we see the EAX was 2. So before we jump, EAX need to decrement by 1, become 1. So then here we will jump to, because 1 is not equal to 0, so we jump to the L1. Okay, so then you see your EAX will have the value 3000 to AX. So then they still need to, even your AX now have 3000, become 6000. But afterward, EXI actually is continue to add. So at the end, there will be end of the loop, end of the array. So then you see your EAX equal to 1. You need to decrement by 1, become 0. So then EAX equal to 0. So I don't jump to L1. I just go to the next one. So that's array sum example. So please make sure you were using this example and run on your IDE. I have source file from the demo file. So also in the lecture video, I show you the source file where you can download from. So that's why I make sure you will run on the array sum. So here you have array sum array loop.asm file. So upload to your project, chapter 3 project. Okay, so then you will see here, that's what we have. Also, this one actually a little different, the sum array. So this one actually we're using the different example. You see that's the int array. Data type is dword. So we have 4 elements. So you will see the same thing. They have, you see you can use EDI or ESI, they both using for the offset. So we save the int array location. So your ECX actually is the length of the array. So then here, because this value is dword, so earlier in our handout, we're using AX for the sum. But now here, because you are dword, so that's why we need to using the EAX for the sum. So EAX equal to 0. So then you will see the same. Even as dword, we still have the loop. So inside the loop, we add the value from EDI point the value is. So we add to EAX. So then every time using the type, we know how much byte we need to add to the EDI. So that's why it's your loop. So make sure you will run this program to see 1 by 1. So that's why the first thing we will see the program run fine. But you see no display, right? That's because you see here in our so far everything, we don't have any value display yet. So that's why now you will see here, if we run the debug mode, you have the checkpoint. So here in the watch window, okay, you have EAX value. Okay, so then here you will see, and then we add EDI. So then you just need to continue to run. Okay, so in the loop, you will see EAX equal to 0 now. So EDI is the location. Okay, so then after you add the EDI value to the EAX. So here we say it's 10,000, right? But you will see how come the value is different, because they not display in the hex. So if you want to check, you can display, see, right click the mouse, display in the hexadecimal. So that's why you will see that's the 10,000. So continue, you see the EDI. Okay, so EDI here, be careful, this one is the location. EDI is not the reference, the value yet. Okay, so then we just see, we do the loop again. Okay, so then you will see EAX again. They will add the new value from the EDI. But EDI here, be careful, they will display the memory location. So that's why earlier is 4000, right? So they display 4 because we're only using EDI. If you want to know the value, you need to use a square bracket. But I'm not sure which window you can do the square bracket. So let's try. Yeah, you see they don't allow you to do that. They only can give you the radius value. So how they dereference, actually we didn't show in the watch window. Okay, but now you can see again, you just continue. Okay, so your EDI increment by 4. So then you see they add to the EAX again. So then when you add to the EAX becomes 60,000. Okay, so make sure you will run on your IDE through all the source file we gave you. So we have a couple more minutes left in this video. So the next one I want to show you is, this example may be a little weird, but one thing is I just want to show you, since our loop only can using the EAX as a counter. So if you need to code a loop within another loop, remember in C++ we call that a nested loop. So you must save the outer loop counter EAX value before you go to the inner loop. So in the following example, actually they just have outer loop. They will do 100 times. And the inner loop, you will do 20 times. So that's why you will see actually they will totally do 100 times 20. So they will execute 2000 times to increment the AX. So we see what happened here. Right, so we have the count on D words. I don't initial the value. So this count actually is later we will temporarily save the ECX value. Okay, we see what's going on. So actually we make the AX equal to 0. So every time when we execute, we just increment AX. So outer loop is 100 times, inner loop is 20 times. So afterward, your AX will become 2000 times because that's how many times they execute. But here we just, on purpose, we do the outer loop here. So the outer loop, you just want to do 100 times. So that's why before your outer loop, supposedly how many times you need to do? You need to do before you go into the loop, beginning of the loop, you need to assign the ECX value. Yeah, so we have 100. So after you're done, right? Good. So then your outer loop is just counting how many times for 100 times. But each outer loop iteration, we need to do 20 times for the inner loop. So on the other hand, this one is the inner loop, L2. So the inner loop, right, I need to have the EAX, the ECX do 20 times, right? So that's why I need to move the 20 to ECX. But the problem is what? You already move ECX equal to 100. You want to do 100 times in the outer loop. But one thing is, each iteration for the outer loop will also have the inner loop to do, right? So that's why here, your inner loop need to do. So you still need to use the ECX. So on the other hand, before I get to the inner loop, I need to save my current ECX value to another location. So later, I can restore before my outer loop finish. So that's why you see here, after my EAX is saved to the count, I can move the 20 to ECX. So inside my inner loop, I just increment AX each time. So then I'm done. But you see here, actually I need to do 20 times. So after I do the 20 times, AX become 20, right? So then you see my outer loop will almost finish. But when my outer loop finish, I need to have the correct ECX value. So that's why here my ECX needs to be restored from the count. So then now the loop, before I jump, I will using the correct corresponding ECX is for the outer loop. So before I check, should I jump or not? So here just a simple example. I didn't do much, but we just want to show you when you have the nesting loop, because we only use the ECX as a counter. So you need to restore that.